So I'm going to use this to prove the Pythagorean theorem using the right triangle similarity. And the right triangle similarity theorem says that if I draw an altitude from the right angle down to the hypotenuse, I draw, and it's an altitude because of this, it's perpendicular, I create three similar right triangles. So the first thing that I always do when I have these is I draw my three triangles out separately. So I always start with the largest one, and I always, just because it's a habit for me, I always put my right angle in this lower corner. And please forgive me, I'm using my mouse to do this, so they're not going to look perfect. But for this one, my right angle is at A, and because I'm doing the largest triangle right now. So my right angle is here, it's at A, and then I always kind of do it so I have my shorter side at the top and the longer one down along the bottom. So I end up with this triangle. I'm going to go ahead and name this triangle BAD. Okay, so now I'm going to do the same thing. I'm going to draw my other two triangles and I'm going to make them look the same, because if I can make them kind of look the same, then it's really easy to see what it is I need to do from there. So I'm going to draw the second one here. Again, I'm going to put that right angle in the lower left corner, and then the longer side down at the bottom. So this is my right angle, and my right angle on this triangle is angle C, and then my shorter leg, as you call it, would be A, and my longer one would be B. And I'm going to name it the same way, start in this corner and move around, because I know that this angle is going to be congruent to that angle, and this would be triangle ACD. And then I'll go ahead and do the same thing for that smallest one, this one over here. Again, right angle in the lower corner, shorter side going up, and again, just habit. I know the right angle is going to be here because I know that this altitude is perpendicular, so that would make this a C. My shorter one would be B. My longer one is A. So now I have, and this would be triangle, again, starting in the same corner and working my way around. That's triangle B, C, A. Okay, so now, in order to prove the Pythagorean theorem, I'm going to want to write some proportions. So the first proportion that I'm going to write is going to be with this biggest triangle with this one, and then I'm going to do the bigger triangle with that one. Because the whole thing I'm trying to prove is, this is what I'm trying to prove. I'm trying to prove that BA squared plus AD squared, those are my two legs of the triangle, are equal to the hypotenuse BD squared. And this is what I am going to attempt to prove using these the similarities. So I know that these three triangles are similar, and I know that means that I can write some proportions of the triangles. So I'm going to go ahead and do that. So for the first triangle, I'm going to start with saying, okay, well, I know that AD, that's this one, over the one in the same spot on this triangle, so that would be CD. I know that that's going to be equal to the hypotenuse on this one, which is BD, over the hypotenuse on this one, which is AD. Okay, and then I'm gonna do some cross multiplying real quick, and I'm gonna say, okay, well, that means that AD squared is equal to CD times BD. I just cross multiplied to get that. Okay, so that's these first two triangles. Now I'm going to do the first and the third triangle. I'm going to do that over here. I'm going to say, okay, well, I know that BC on this triangle, that's this shorter side, is going to be proportional with the same shorter side on the first triangle, BA, and that is going to be equal to the shorter side of the hypotenuse on this triangle, which is BA, right, over the hypotenuse on this triangle, which is BD. Okay? So then again, I'm going to do my cross multiplying, and I'm going to say, well, okay, that means that BA squared is equal to BC times BD. Okay, so now I've got this, and I've got this, and I want to use those to prove that. So I notice there's some addition there. I'm going to go ahead and add those two together. So I'm going to say, okay, well, if I take and add the AD squared plus BA squared, I can say that that's equal to CD times BD plus BC, I'm so sorry, my handwriting is this awful, BC times BD. Okay, well, that means if I notice on the left side, this side over here, I see that I have a BD in both of these. So I'm going to say, okay, well, that means that's equal to BD. I'm going to factor that out, and then I'm going to get CD plus, I should say, I'm so sorry. Oh, let me fix that. Sorry about that. CD plus BC. Okay? And now, if I come back and I look, I see, oh, well, BD is my hypotenuse in my original figure, which is made up of parts CD and BC. So really, if I say, well, I know that that I can add BC and CD and get BD, so I'm just going to replace this part with that, I can replace that part with BD, which makes this BD times BD, and I end up getting this. I end up getting my Pythagorean theorem. So I have proved it using the math. And I started by, like I said, drawing out my three triangles so that it was very easy to see which sides were proportional to which, and then using that to create proportions, cross multiply, and then add the two together, and that is how I end up solving that. I hope that helped.